tutorial for 5.2 practice section, problem number 6. And what we're being asked to do here is find all the zeros of a particular function if we are given a single zero. And that clue right here, this f of 9 equals 0, is our clue that basically starts this domino effect of finding all possible zeros for this function. So if 9 is the 0, that means if we are going to use synthetic division, which I am going to use for this problem, we can put 9 into the box in order to start setting up our problem. All right, so I've set up the problem. Of course, the 9 goes into the box, and our coefficient 2 is right here, negative 10 is right here, negative 71 is right here, and our constant negative 9 is right here. And one thing this problem makes convenient for us, is that there is no missing term. So we don't have to create a placeholder for a missing term in descending order. We have an exponent of 3, exponent of 2, exponent of 1, and an exponent of 0. All right, so let's start this process. First things first, our 2 drops. And then we take the bottom times the box, 2 times 9 gives us 18, and that goes there. We add, negative 10 plus 18 gives us 8, and bottom times the box, 9 times 8 is 72, and we add, and we get 1. 1 times 9, bottom times the box is 9, and negative 9 plus 9 is 0. That is the remainder. And if they tell you that 9 is a 0, you should get a remainder of 0. If you don't get a remainder of 0, you've done something wrong. So once we get to this point, this is where a lot of students start to kind of freak out a little bit. They're like, okay, what do I do now? I know I have a 2, an 8, and a 1. What next? Okay. And the strategy here is to recognize that this little guy right here is your constant, plus 1. The 8 is your x term, and the 2 is your x squared term. So basically what you have done is you have just created a new, essentially a trinomial here, plus 8x plus 1. Okay, so that is our new trinomial, and we can start to break that little fella down, whether it's factorable, because when we're finding the zeros, we want that to be equal to 0. And we need to find those x values that will help us find the 0, or where our equation will equal 0 at this point. And our strategy for figuring out the zeros has been so far to factor. And I see this little 1 right here, and that's pretty much a clue with the 2 and the 8 floating around in the x squared and the x term that this is not going to be a factorable expression. So our backup plan, if it's not factorable, is the quadratic formula. All right, so let's kind of start to get the quadratic formula set up. I'll be right back. All right, so I have plugged in all of my a, b, and c values into the quadratic formula. And if you're having trouble memorizing the quadratic formula, let's sing it for just a moment. All right, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That should help you memorize it. If you never have been exposed to that song, you're missing out. All right, so I completed step 1, and one of the things I noticed, particularly on the final exam, is that a couple of you, specifically my pre-calculus students, are stopping with this little step, the discriminant. And some of you just took like 64 minus 8 in order to get 56. Let's kind of get that started. Oops, I don't like that. Hold on, be right back. All right, so I'm back. So a couple of you got to this point on the final, or whatever problem it was, I can't remember, and you looked at this 56 right here and said 2 real solutions, and then you stopped, okay? And of course, if you were being asked how many solutions are there, that would be a correct answer. But notice it is actually, the problem is asking us to find all the zeros. So we do need to extend this problem and basically finish it and continue to simplify and solve. Alrighty, so what I have done with this next step is, obviously 56 is not a perfect square, but odds are 56 has a perfect square factor floating around inside of it. So what I have done here is I've taken 56 and I've divided it into the square root of 4 times the square root of 14. And 4 times 14, of course, is 56. And so what that does for me is it takes 4, which is a perfect square, away from the 56. And I did have some mistakes, kind of random mistakes occur over the last little while that I've seen on homework and such here as well. So I wanted to point that out, how we take care of simplifying radicals. So from there, we can actually take square root of 4 and simplify it to 2. And the square root of 14, of course, we can't simplify any further, so that remains square root of 14. Okay, so from here, we do need to make sure that we reduce if possible. Okay, and so what I'm seeing here is that -8 and 4 can reduce, and the 2 and the 4 can reduce here as well. And we want to make sure that we handle that. 4 has to be divisible into the outside term, that -8, and into the 2. So let's see what that looks like. All right, so -8 divided by 4 gives us this -2 right here. And 2 over 4 gives us, essentially, there's an invisible 1 over 2 right here. Now, a lot of students look at this and say, well, -2 and 2, I can reduce that. No, we cannot if there's not it's almost like a greatest common factor kind of thing. We have to do it has to be divisible into both pieces, okay? The one that's in front of the radical and the number that's out front. Okay, so this is our final answer here for solving of the quadratic formula. So we basically have to list as our answer all of the zeros. Well, we've been told one of the zeros was 9. That's from the problem way up here. Okay, our other 2 zeros is x equals -2 plus or minus root 14 over 2. And that makes sense because if you remember, our degree in this function is 3. So we should have 3 total solutions. All right, whether they are real or imaginary, and we have 3 solutions.